Hi students, welcome to Royal Chem Chemistry classes. So today we are going to discuss about one of the important portion in organic chemistry, that is reagents in organic chemistry. So in previous year exam, even IIT JAM exam, GATE exam, CSIR-NET exam, lot of questions asked based on the reagents concept. So you can expect, if you took the CSIR-NET exam, you can see that 15 to 20 mark question asked from the reagents portion itself. So basically there are many kind of reagents in organic chemistry. We can have reducing agent, we can have oxidizing agent, we can have organometallic reagent. So many reagents are there. So today specifically we are going to discuss about the oxidizing agent, that means oxidizing reagents. So let us look into that. So oxidizing agent or oxidizing reagents. So what is basically oxidation? You know that from our basic classes, oxidation is nothing but simply addition of oxygen or removal of hydrogen. So mainly we are going to focus on the oxidation of, first of all we are looking for the oxidation of alcohol into aldehyde or ketone. Okay, depending upon the nature of alcohol. If it's primary, then it will go to aldehyde. If it's secondary, it will go to ketone. After that, we will be looking to the oxidation of alkene. The most common reaction of oxidation of alkene is epoxidation reaction. You can see that the alkene is alkene. In this alkene, it is inserted. Oxygen is inserted in this oxygen double bond. That is oxidation reaction. This kind of reaction is known as epoxidation. Okay, and finally we will look into the oxidation of ketone. Oxidation of ketone into ester. So these are the main oxidation we are going to discuss here. So now we are going to discuss about specifically oxidation of alcohol. Okay. So oxidation of alcohol. So basically oxidation of alcohol can be carried out by using mainly two metals. First metal is chromium-based oxidation, and second one is manganese-based oxidation. So these are the main oxidation in which we can carry out during oxidation of alcohol. So now we are going to discuss about the chromium-based oxidation. After that, definitely we will going to look into manganese-based oxidation. Okay. Now let us discuss about the chromium-based oxidation agent. So I have already given a table here in which you can easily see that chromium-based reagent. There are four chromium-based reagents are here. In first column we have reagents, secondly we have nature and conversion of the reagents, and finally we have remarks. If something important specifically for that reagent, that is given in the remarks. So our first reagent is chromium-based. First reagent is Jones reagent. Jones reagent is CrO3 plus H2O, H2SO4 plus H2O plus acetone as a solvent. Otherwise, you can given that NO2Cr2 also. That is also another form of Jones reagent. So nature of this Jones reagent is a powerful and strong oxidation agent. It will convert, since it is strong oxidation agent, it will convert primary alcohol to aldehyde. Thereafter, it will over oxidize to carboxylic acid. Secondly, it will oxidize secondary alcohol to ketone. There's some important point about the Jones reagent is it will over oxidize primary alcohol to acid, and it will react with the acid sensitive group. That means if you have any acid sensitive group in your reagents, that means if acetal, any acid sensitive group, that will also react in presence of Jones reagent. That is one of the drawback of Jones reagent. Now second reagent, that is Collins reagent. Why scientists introduce another reagent that we know that Jones reagent is a strong oxidation reagent, so that it will over oxidize primary alcohol into carboxylic acid. So in order to control that primary alcohol to up to the oxidation into aldehyde, scientists introduce another kind of chromium-based reagent, that is Collins reagent. Collins reagent is CrO3 plus pyridine plus lithium. It's a mild oxidation agent, so that it will oxidize primary or secondary alcohol into aldehyde or ketone. So after that, again scientists introduce another kind of oxidizing agent, that is PCC. PCC, in which we are using CrO3 plus pyridine plus HCl. And this is also mild oxidizing agent. This is also mild oxidizing agent. It will also oxidize primary or secondary alcohol into aldehyde and ketone. So one of the important point about the PCC reagent is that it will undergo one of the important name, that is Babur oxidation. We will discuss that in later. So finally, again one more reagent which in which chromium metal is used. That is PDC, pyridinium dichromate. PCC is pyridinium chlorochromate. So PDC, you also PDC you have chromium oxide, you have pyridine and water. In PCC you have, instead of water you have HCl. In PDC you have water. Okay. So this also mild oxidizing agent. Again, it will convert primary or secondary alcohol into aldehyde or ketone. But the important point of the PDC is the effect of solvent. If you are using solvent PDC in presence of DCl as solvent, dichloromethyl solvent, then it will oxidize primary alcohol into aldehyde, just like a mild oxidizing agent. But the thing is that if we are using PDC in presence of DMF as a solvent, it will act like our Jones reagent. That means it will oxidize primary alcohol into carboxylic acid. So this is what the summary of the chromium-based metal oxidation. There is no need of to study the mechanism of the reaction. Or every point is already given or consumed here. Okay. Now let us discuss about the some of the previous year question based on the chromium-based oxidation. So question is that we have given alpha beta unsaturated ketone, then treating with Grignard reagent. Second step we are treating with DCC. So we need product. The major product obtained in this above reaction is the four option is given here. Okay. This question asked in previous year NET and GATE. So let us how to approach this question. We have alpha beta unsaturated compound. If we add in Grignard reagent CH3MgF, you know that in presence of alpha beta unsaturated compound, Grignard reagent acts as a 1,4 addition product. 1,2 addition. Because Grignard reagent is a hard nucleophile, the carbon is also hard center. So you will be getting O minus here and CH3 here. Now we are using acidic condition. So this OMH will be neutralized into OH. So this will be our first product. So if you look at this product, we know that it's a tertiary aldehyde alcohol, and we have the second step PCC. So it will undergo Babler oxidation. Now we have already discussed how to solve the Babler oxidation. If you given this aldehyde alcohol, we can approach through a tricky method that we have already discussed. That means if you shift this tertiary alcohol OH is here, then double bond will shift to here. So you will be getting double bond here, OH here. Again, it will oxidize into this alcohol will oxidize into ketone. You have alpha beta unsaturated compound. This alcohol will oxidize in presence of PCC into ketone. So the option is B option is the correct answer. So this question asked in previous year NET and GATE exam. So thank you for watching Royal Chem chemistry classes. Thank you.